Please welcome Kevin Smith.
Thank you. So I just want to make sure I can bring this presentation up. There we go. So yeah, thanks for having me. As Haroon mentioned, I'm Kevin Smith. I'm the CTO of Tridium. And for a very long time, my focus has been, and my passion has been, cybersecurity. And specifically at Tridium, one of my big focus areas has been the cybersecurity of our products. So, specifically building in strong cybersecurity controls in the software of the Niagara framework, which runs on embedded devices and in supervisors, but also in our embedded hardware. And so today I'll be talking about cybersecurity consideration in smart buildings. You can also apply this to the IoT in smart cities. So I hope you'll find this informative. Over the past 5 years, there has been a massive number of cyber attacks, data breaches, viruses, malware, ransomware, and vulnerabilities in products and protocols that we thought were secure. I remember 5 years ago in 2014, everyone nicknamed 2014 the year of the data breach. But then the next year, it was bigger. And then the next year, it just got bigger, and there were more breaches. Breaches that affected so many companies and cost them millions and millions, and in at least one case, billions of dollars for a cyber attack, right? This is a challenge that affects all of us in every sector of business. It certainly affects banking companies. We've seen that with some of the data breaches just since I built this slide recently, right? But we've seen it in the buildings industry. We've seen it in the industrial industry. Every single industry, it affects all of our lives. And it's important for us to know that cybersecurity matters. And as we talk about smart buildings, as we talk about intelligent buildings, and as we move to smart cities, it's important for us to acknowledge the changes that have happened in this industry. So 15 to 20 years ago, as we've looked at when people first started using Niagara for controlling things in buildings, there used to be a smart building system that was physically connected to edge devices, right? Through cables and wires. And they all spoke protocols like BACnet and LawnWorks and Modbus. And a lot of these systems are still around and are in use today, right? We're never meant for IP networks, or we're never designed with cybersecurity in mind. And so that's a challenge. Another challenge is sometimes if they're all speaking legacy protocols over IP, unless you have a middleware component, it's hard to build a cohesive solution together. Finally, many of these devices also have cloud applications and architecture, so you can control these devices with your phone. We've seen this in the home, and we're starting to see this in business, right? Being able to control your devices with your phone over the internet. This implies that there's some application in some cloud architecture somewhere that you don't control, right? Do we know about the cybersecurity consideration for those applications we don't control? So, like I said, many opportunities, many challenges. As Jack mentioned, we seem to be connected to everything. Everything is connected to everything. The challenge with that can probably be summed up with a story. And I like to tell this story because it does demonstrate the challenges. This came out a few years ago. A casino in Las Vegas wanted to remodel. And they wanted to build a huge aquarium. And if you've ever been to a casino, there's bright and shiny lights and colorful things. And they said, let's get a big aquarium and let's put beautiful exotic fish in it. And one guy said, hey, if we're going to go big, let's go smart. Let's get a smart aquarium and let's connect it to our network. And that way, we'll be able to control it with our phone, right? And sure enough, they got a huge aquarium, this beautiful, beautiful fish. And a facility manager got his phone, said, wow, look at this. I can tell you what the temperature is in that aquarium. Do I need to add anything? No. Do I need to, how's the salinity? How's the alkalinity? Everything's great. So one day, somebody said, why is the network so slow? Why do you guys think the network was slow? It was the aquarium. What was the aquarium doing to make the network slow? Turned out the aquarium was infected with malware. And this aquarium was attacking every device, every computer, every system on the casino's network. And unfortunately, it was doing it successfully. On one computer on the casino's network, there was a database of VIP gamblers who used that casinos, had a lot of sensitive information about those gamblers. That was broken into, stolen by the aquarium, and then streamed out over the internet. Friends, this demonstrates some of the challenges related to our new normal. Every system, every device that you connect to your network has the potential to be a Trojan horse in your organization, attacking every system, every device, every computer in your organization, or using your organization's assets to attack others. So before you connect any new device to your network, you have to ask yourself, was this manufacturer of the device cyber aware? Because guess what? Some are not. You have to ask yourself, does this manufacturer have cybersecurity processes? Do they bake in cybersecurity controls or good cybersecurity controls? Because guess what? Some don't. Some cannot justify the expense of focusing on those cybersecurity controls in their products, and say they don't. Also, almost as important, will this manufacturer actually support the product? If there's a vulnerability in the product, will they release patches in a reasonable amount of time? Because many won't. And as we look beyond the manufacturer, we have to ask ourselves, well, who connected this aquarium to the network? Right? With any device, who connects that device to the network? Is that person cyber aware? Who configures that device? Is that person familiar with cybersecurity best practices? Who sets up the network that the device is connected to? In the aquarium's case, it was set up in a network where that aquarium had access to connect to anything on the network, right? Who's in charge of setting up the network in that organization? And then finally, for all your devices, for all of the things in your network, who's monitoring your systems? Who's monitoring your new devices? What is that device doing? What is it communicated with? Is it behaving in an abnormal way? All of these things are very important in your organization. And this is kind of foreshadowing of some of the things that I'll be talking about in today's presentation. So what I'm going to do is I'm going to talk a little bit about the threats of cybersecurity. And because it's really important for you to understand those threats in order to prepare to defend against them. I'll talk about some organizational best practices for defending against the cybersecurity threats, and then I'll get into some just general best practices that I have, and then I'll leave you with some resources. Hopefully we can share this presentation that has some links to some resources, some white papers from Phoenix Contact, also a white paper from Tridium that I can share that goes into greater detail. But this is kind of the agenda. One thing that I can't understate is the appeal of cyber-physical systems, the appeal of the IoT, the appeal of control systems to hackers. Because this is where the virtual world meets the physical world. This is where, through a network, somebody could turn things on, turn things off. Someone could change things. Somebody can turn things up, turn things down. So initially, we saw some funny things, right? Like the picture in the slide behind me. I'm from Virginia, and in Virginia and highways, we have these signs, and sometimes they say, hey, exit 79, traffic accident, expect delays. Well, when these first started coming out, hackers figured out how to change these signs, and so you would see things like, beware, exit 79, zombies, put on your helmets, protect your brains. Kind of funny, right? Not so funny when a grocery store chain has its refrigeration cut off and they have to get rid of thousands of dollars worth of food and they have thousands of dollars worth of losses. Not so funny, a data center that controls a lot of computer equipment having its cooling cut off, losing millions of dollars worth of equipment. Or a hotel having its doors locked through IoT door locks and being held for ransom, or the people can't leave the hotel. Or think of even the terrorism considerations related to threats to life safety with some of the devices that these systems control. So this is a very important topic. I have a quote up there by somebody who's fairly controversial. Eugene Kaspersky owns a security company. He says, if you have a control system that is connected to the internet, it has a 100% chance of getting hacked the first day. And I think what he means is, if it's exposed to the internet, if it's discoverable via the internet, if someone can get to it from the internet, it does. And I think this is true because control systems are targets of great value. The other reason is there are a lot of tools that allow hackers to do this. Raise your hand if you're familiar with the website Shodan, or Census, or ZoomEye. Okay, so we have some hands. That's really good. Shodan, years ago, when it first came about, people started referring to it as the Google for hackers. Because like Google, Shodan indexes data about things on the internet. But unlike Google, what Shodan does is it indexes data about connected devices. Devices connected to the internet. What software is running on those devices? What versions of the software? What ports are open? What version of software are running on those ports? Indexes all that information and allows it to be available. And then couples that with vulnerabilities associated with those products. So unfortunately, on Shodan, a popular search term is, give me routers with factory default usernames and passwords. Who's gone to the store and ever bought a router for your home, like a wireless router? So usually, if you look at the manual, it says, hey, to set up your router, the username is admin, and the password is 1234, but make sure to change it. Well, it turns out a lot of people don't change it. And you can find them all on Shodan. All you have to do is do a search for routers with default usernames and passwords. You get a response, you click on the link, you log in, and then you own that network because it's the router. It's the entryway into that organization. Same way with web cameras. That's another big search here. And unfortunately, same thing for control systems. Shodan actually has a page dedicated to control systems that are exposed and discoverable via the internet. And man, I hate to even say this, but I'm going to say it because I think it is important. I was giving a presentation earlier this year, and I was talking about Shodan, and I was talking about the fact that control systems are exposed. And much like the wireless routers in that example that I just gave, about a decade ago, Tridium used to have default credentials in the Niagara framework, and we would say in our manual, hey, make sure to change it. Well, it turns out some people didn't. And so, because of that, we've made some changes, and so now we force people to change credentials before they actually set up their system, right? But some of the older systems, unfortunately, they're on Shodan. And I shared this with a training class, and about 5 minutes later, this guy goes, "Hey, I'm in." I said, "In what?" He said, "Oh, I just logged into a hotel." And I said, "What do you mean?" He said, "Oh, I just did a search on Shodan for Niagara, clicked on the link, and I got into a hotel." And I was like, "Please don't do that." So the problem is, and so we're trying to educate our customer base, certainly, about, please, don't do this. One, if upgrade your systems to systems where we actually force this, and have, their later more supported versions. But two, never expose your system to the internet. And I was talking to the Intelligent Buildings Conference a few months ago, and somebody said, "Well, hey, if I have a question. If my system isn't connected to the internet, do I even care about security at all?" And so I shared this quote that's on the screen behind me. This person is a friend of mine. I went to college with him. Turns out he does risk assessments for control systems. I didn't realize that until I read the article and recognized them. And I talked to him a little bit after I read this article, and he said, when I do risk assessments, the first thing I ask is, tell me how your control systems are connected to the internet. And they all say, "Oh, we're not. We're air-gapped. We're not connected in any way." And he said, almost 100% of the time, they're wrong. And so this is a big challenge for our industry because there are lots of people involved. Usually an owner hires an integrator sets it up. The owner may just think that the system is set up in the most proper way, and sometimes it's not. Or sometimes the integrator sets it up in a proper way, but time goes on and people connect cables to different ports and things change. So this is a big challenge for our industry. So let's talk about organizational best practices. In order to find a solution, the solution revolves around technology, certainly, and a lot of times we gravitate to technical solutions when we think about cybersecurity because technology is very helpful in coming up with secure solutions. But it revolves around people. People are often the weakest link in cybersecurity. People need to be trained. People have to understand what the threats are in order to know how to defend against them. They have to know about the proper use of technology. You've heard of people clicking on an email attachment and getting malware on their computer, right? That's understanding, hey, you shouldn't click on attachments from certain sites, or you shouldn't click on certain links. You should know what to watch out for. The same is true related to the proper use of software related to the control of buildings and the control of cities. People have to understand processes and procedures, things like patch management, patching your products, best practices for configuring control systems, incident response, on and on and on. And it's also really important to realize that not only should you have policies, but they should be communicated well, people should be trained in them, and people have to know that they're going to be enforced. Because if you remember the slide that I had, one of my first slides had headlines of some of the cyber attacks of the last few years. If you start diving in to why those organizations were attacked, certainly some had flaws in technology, right? Sometimes their network wasn't set up in the proper way, or sometimes they didn't have intrusion detection systems, or things were configured bad. But in many cases, you had great technology in place, you had organizations who really cared about cybersecurity, and they had great policies and procedures, but for some reason, When users were alerted, they ignored it. So my guess is either they weren't trained very well in it, or they didn't think that the organization was taking it seriously. So people really is an important part of the solution. Another important part of the solution to think about when you're thinking about the cybersecurity of your building, it's not just the cybersecurity of your control system or of your individual edge devices. It's a holistic view of everything, right? Kind of like that aquarium example that I was talking about. You had an aquarium. It was connected to a network. You have to think about how's that network set up? Was a defense in depth approach used in setting up the network? Was that aquarium isolated from the other things on the network so it couldn't attack it, right? You have to think about how's that aquarium configured? Who was configuring it? Were they using best practices? What are the other things on that aquarium's network? Is anyone managing those other devices on the network? Who's monitoring all those devices on the network? Who's patching all of those devices on the network? All of these things are very important. And finally, who are the users of the network? How are they using the network? Could any of those uses provide risk to the network? So you really do have to have a holistic view of everything on your network, what everything's connected to, because each one could be a weak link, and the weakest link is sometimes the avenue of a cyber attack. Another thing that's very important is understanding that cybersecurity of your organization extends beyond your organization. So if you're using products, it begins with the product supplier or the manufacturer, right? It involves many times the integrator, the person who's setting up that system, the person who is configuring your networks. It involves you if you're the owner. It involves the asset owner, the maintenance provider, the people who are using your systems, and various authorities, right? And so I've taken this from a standard called ISA 62443, which is a great standard for industrial control systems. In fact, we use ISA 62443 for the security requirements of our products because it really does have a very good explanation of the type of controls that all industrial control systems could use. But it also goes beyond just security requirements. And I've taken these slides from that group, and they kind of talk about a product life cycle. And the product life cycle starts with product development, where your manufacturer builds in cybersecurity controls into the product. There's a security software development life cycle and hardware development life cycle. It involves installing security capabilities. It involves pen testing, security testing. But it continues. So Tridium, for example, we build this into our products. We release the products, but then we continue. We continue to look at it. We continue to test it. And then we continue to support it and patch it. That's really important for customers to know because as they have our products, they have to realize that, hey, we need to keep on checking for updates. Because when we find that there's a vulnerability in a protocol that we use, we're quick to patch and release the patch. But if somebody isn't actually applying that patch, they're potentially in jeopardy. The integrator has a really important role too. The integrator, depending on the contract, sometimes has one of the biggest roles, which is sometimes configuring the networks, configuring the devices, setting up everything, and coordinating with the organization, right? Sometimes the integrator has the responsibility of setting up processes in place, and sometimes also takes the role of maintaining that system. But it doesn't end with them, because a lot of times the integrators come in, they install things, and then they leave. And then you have a system that shouldn't be left alone, right? It requires continuous management, applying patches, monitoring that system. If it's an aquarium, what's that aquarium doing? Is it acting abnormally? Things like that. Finally, I want to talk about some just general best practices that you can apply to connected buildings. And one is more of a historical challenge, and I guess maybe a social and cultural challenge. OT, or operational technology, historically facilities groups who are tasked with setting up and maintaining control systems. And IT, information technology, have had a disconnected and rough past. And it's funny, I was speaking at IBCon at a session on this, and Jim Young, who is kind of the spokesman of Realcomm, who is the moderator of that group, he's like, what's it going to take for OT and IT to come together? And somebody raised their hand and said, death. Because the OT people see the IT people as the people who say no. No, you can't connect this to my network. No, you can't open this port, right? And so as a result, sometimes the OT people try to get around IT. And they do this by becoming shadow IT. The challenge with that is the IT professionals usually have that networking background. And they have this background of making sure that things are set up in a secure way, in a way that maybe the OT people don't. And in the same way, the IT people who don't want to work with the OT people see them as, oh, they're dealing with these archaic systems that I don't want to deal with at all. And they don't realize that the OT facilities people are troubleshooters. And they really understand that technology well. And so in order for there to be a good solution, OT and IT really have to work together. And we're starting to see it happen slowly. We're starting to see that cultural change, but it is a change in culture. But it has resulted in, sometimes people exposing their systems to the internet. When the organization doesn't think that those systems are exposed to the internet, and that is changing, and that's a positive change when OT and IT work together. Another best practice that I'm starting to see more and more in this community, and it's very healthy, periodic risk assessments. We all need to know what's on our networks. What kind of assets do you have? What software is running on those assets? What are the risks associated with the assets on my network and the software running on them? It's important for us to know this because, typically we don't know. Typically when you talk to people who are assessors of networks, they go in and they say, hey, give me a list of all your assets. Give me your network topology. And then at the end, they give them a list, hey, here are all the assets you didn't know about. And here's your real network topology, right? Our networks change over time. People connect different things to the network. Our networks have become kind of living, breathing organisms, right? So it's really important that, one, you identify your assets, but you have somebody, an external third party, come in and evaluate your system for risks, because this does affect the cybersecurity of your building, of your system as a whole. Typically, when you do this, you usually want what's called a bug bar. They usually rank risks, and you say anything above this risk, before I know even what one of the risks are, I'm going to fix everything above this line. Medium, high, and critical. And then I need a plan for everything below that. And it's really up to the organization to define this line, right? But I found this to be very helpful. Organizations have found risks that they had no idea they had. And It's also very helpful to do this periodically because, as I said, your networks change over time. Your building changes over time. Every building changes, and so you have to periodically do this. Product manufacturers play a pretty important role too. I've talked about the importance of people and the people, processes, and technology, but you can actually enforce good behavior through technology. And so I'll give some examples of what Tridium has done. It is just an example. So 5-6 years ago, we were re-looking at Niagara as we were planning to release Niagara 4. And so Niagara AX had been around for a very long time. And so we wanted to take a holistic view of the design of our product. So one, we looked at that standard ISA 62443 and tried to say, okay, let's look at the highest levels of security for industrial control systems, and let's identify the gaps and let's fill those gaps, right? But as we were doing that, we started thinking about the importance of the people aspect in technology. We realize as you look at people, how people use systems, phones, anything, usually people select the defaults, right? And so we said, well, why don't we make Niagara secure by default? Let's make it default to the most secure configurations. And so that's what we did. So one of the first things we did is we made it so that even though to set things up, we have factory default credentials, we force the user or the administrator setting up a system to change those before they can deploy a system. Because we didn't want a situation like the wireless router, like someone actually choosing the default credentials. Also, like when people add users, they just add a user. We figured we don't want the integrator to have to be a security expert. So behind the scenes, it uses the most secure authentication scheme. It forces the user to have a strong password due to OWASP recommendations and things like that. So we're doing things like that and defaulting to secure communications only, and which I really think is the right thing to do. So the good thing is when people choose the defaults, they choose the most secure recommendations. We also added the capability for role-based access control, which I think is a little easier to manage for authorization than permission-based access control. But then we started doing things that didn't require configuration at all, which I think we needed to do, and it's been very helpful. So, good example. With the Jace 8000, with our embedded devices, we do secure boot. So at boot time, it validates the integrity of everything on that device. And if a malicious third party or malware has altered the software running on that device, it won't boot. We thought this is important because sometimes this is what malware does. It goes in and it attacks a computer system and it modifies it without you actually knowing, right? And so we wanted to, at the boot process, to recognize that and stop the boot if something like that were to happen. After that, what we do is, as we're loading the core Niagara software, we validate the integrity of the core software at runtime. So if anything has been manipulated or altered, it'll stop running. Finally, we added sandbox controls for anything running on top of the Niagara framework, so that they had to have special permissions to do certain operations. So this is what we've done because we felt like it makes the software easier to use, easier to configure, and more secure than if we allowed all the detailed security configurations up to every user. And so this is an example of what manufacturers can do and are doing, and I can see this elsewhere in the industry, and I think it's helping. And so, oh shoot, these are the older slides. Another great best practice is defense in-depth networking. And so one of the resources that I like to go to is ICS Cert through Department of Homeland Security. And ICS Cert has a great paper, Recommended Practice Improving Industrial Control Cybersecurity with Defense in-Depth Strategies. And it talks about separating your network into zones and having your control systems into a control zone so that it's not directly connected to the other elements of your network. Think about the aquarium example again. That aquarium was successful in attacking everything in the building because it could. If it was isolated onto its own network, you then restrict what that infected device could do, right? So I was sharing this with Phoenix Contact and Haroon, and they said, this is great. We've actually expanded on this in another white paper that we have, and we'll make that available as well. And so what they've done is they've expanded on this diagram and actually expanded on this in a couple different domains. And so we'll make that available. But the concept is the same, separating your network into isolated networks. Very helpful. Patch management is one of the best practices that you can do because if you think about it, so many protocols, so many software applications, so many devices are infected with vulnerabilities every day. And the good people at US CERT and ICS CERT are super helpful in one, identifying the problems, working with vendors about the vulnerabilities in their products, and then finally sending alerts to consumers. And we work with ICS CERT primarily for industrial control systems. If a security researcher thinks they find a vulnerability with a Niagara product, I work with them to see if it is indeed a vulnerability, and if it is, we fix it. We plan to release patches. We release patches to our community, and then we work with ICS CERT to send out a security bulletin and usually thank the researcher. This is a process that we've done a lot, and we work hand in hand with ICS CERT, and other vendors do too. So it's really important that when, for example, Tridium releases a tech bulletin saying, hey, we have a new version of our software, it fixes a certain vulnerability, it's really important that our customers take this time to patch those vulnerabilities. Because we usually do this ahead of time of a security bulletin because it will give our customers a chance to do it before it goes public. Because when it goes public, even the bad guys see this stuff, right? So it's really important in your organization to have someone managing this process, someone looking to see what of my products are affected by these new vulnerabilities that are coming out every day, and when do I patch them? So patch management is a very important part. Ransomware is something that I used to not talk about 6 years ago. Mostly because we were so focused on embedded devices, and embedded devices weren't typically a target of ransomware. Well, that could change any day, certainly. But one thing that is a huge target for ransomware are Windows machines. And so Niagara Supervisor stations run on Windows machines. And so we started getting calls a few years ago that people's supervisors were being infected with ransomware, all their data was being encrypted, and they couldn't figure out what to do. And so as a result, it's really important, as I said before, educate your people on the use of technology, on the dangers of clicking on email attachments, especially. Use of antivirus software is sometimes effective, but periodic scheduled backups is really important too. A friend of mine owns a company, had a lot of IP that he hadn't backed up, and someone clicked on a malicious email attachment. It encrypted not only that computer, but a network drive that had all of his IP, and this person had no choice but to pay the ransom to get the key to decrypt everything, right? If you have backups, not as much as an issue. It's probably a hassle to restore everything from backup, but it's not as much as of an issue. It's important to realize that also another vehicle for ransomware are USB drives. So the physical aspect, sometimes malware is infected on these USB drives. That's another avenue into your network. And what we've had to say for our Niagara customers is, hey, if you have a supervisor machine that's running Niagara, don't use it to surf the net. Don't use it to check your email. Control the physical security of that device as well, because again, USB drives, etc. And I would even go as far to say is, don't put it on the same network as people doing that, because in that example where I talked about, my friend owning the company and somebody clicking on a malicious link, it infected a network drive, right? So if your supervisor is connected to a network where people are checking email, it still has a chance of being affected by ransomware. So it's really important to think about that. Physical security. This is an interesting story. I was given a cybersecurity talk to our training class. And someone said, yeah, we had a problem. Somebody stole our supervisor. And I said, what? They said, yeah, they actually walked into the building, disconnected the machine, and walked away with it. And I said, how could that happen? They said, well, we didn't really think about it. We were focused on configuring our systems securely, which we did, but we really never thought about physical connection to our network. And we had a room that had no badge access. And so this is really important to know, because if somebody actually has physical access to your assets, there are lots of things that they could do. Plug things in, disconnect things, plug things into the wrong networks, etc. And so really important for you to know. And finally, it really is the weakest link, people. Some people call it wetware. People are the weakest link, and it's really important that people and your organizations, any organization, need to be aware of the cybersecurity threats, the proper use of technology, especially related to control systems and the power of what control systems can do. This is very important for them all to know. And we have some resources on this slide that I'll make available. I have a later version of these slides where I do have the Phoenix Contact white paper that's helpful. One of the things that we just updated on our website is a cybersecurity white paper. So I originally wrote this a few years ago. I updated it earlier this year, and one of the big complaints were when we first released this on our website, people actually had to type in their email address and contact information, and a lot of people didn't like that. And so I made them take it out. So you go to our website, you can just download the PDF. You don't have to sign up. There's no paywall or anything like that. Anyway, I hope this is helpful. I'm sure we're going to have a conversation a little later with the panel, and so I don't know if there's time for questions or we can reserve that for the panel.
Yeah, we have it at the end of the event. We have at 3 o'clock expert panel.
Okay.
If we can hold the questions until then, appreciate it.
Okay, well, thank you very much.
Thank you very much.